Hi, the Astro 30 here, and today I'm going to be showing you how to assemble an AM/FM radio kit that I got off of eBay. This video is mainly going to be more about doing the alignment and some of the pitfalls you may run into during construction. It's not going to be a video showing the complete construction piece by piece. No one needs to see me soldering components onto a circuit board. So anyway, this video is sort of to fill the holes that are in the instructions, albeit very sparse instructions. So sit back, enjoy this video. That basically says Superheterodyne pull radio at the bottom, but if you cover the last G at the end there and then put it into Google Translate, it comes out as Superheterodyne pull masturbation. It's amazing how one word changes the entire context of the sentence. That's the circuit board, and all the components mount through the top, all with the exception of the power LED and a little single IC which goes on the back side of the board. Now that's the schematic, and it uses a CXA1691BM. So it's a single IC design, including the power output to the speaker. It's a pretty simple circuit with three coils, two on the AM and one on the FM. There's an oscillator and an IF transformer on the AM side and an IF transformer on the FM side. This is our little front decal. It's just got this tape stuff on the back. So that's our speaker. These are the other parts. Now, plastic wise, the workmanship of this is pretty crap. What do you expect for Chinese manufacturing? There's only one screw that goes in from the back, which locates into here to hold the casing together. Now it takes two D-size batteries, which don't come with the kit obviously. But that's fine. I got a set of 8 of them for $8. That's not a problem. And this kit cost all of about $14 Australian, so around about 11, 12 US. So here's our antenna. Now here's our speaker. It's only a little small thing. Doesn't even look that well manufactured, to be honest. So yeah, this is basically all the instructions you get with it. There's a board overlay and the schematic up the top, and a little bit of reference material down here about component orientation, like the two filters. One's a 455 kilohertz filter and the other one's a 10.7 megahertz filter. Just shows you where the pin numbers are so you know to put it the right way around on the board. However, everything is written in Chinese. So unless you can speak Chinese or read Chinese, this is not very helpful as usual. So basically, to assemble this kit, you're going to have a bit of basic knowledge with how radios work in order to align it. But this is what the purpose of this video is going to be, is how to align it. And really, in retrospect, it's not that hard to align, well, an AM receiver anyway, because you don't need any fancy test equipment like an oscilloscope, although one would help. You can actually get away without using an oscilloscope. So that's going to be the point of this video, but I'm going to start the construction by doing some hardware. Like, I'm going to mount the face panel on that, and I'm going to mount the speaker in. I might also put the terminals for the batteries in there. So with this, all I do is just remove the tape. And then I'm going to put it on the right way around. Preferably in the right spot too. Like that. Now if that comes off, I'm just going to glue it with some super glue. That'll hold it. Now just for reference, the board sits in there like that, so the speaker connection terminals are here at the end of the board, so I just need to know a rough placement of where I'm going to put the speaker. Now there are probably two clamps that I'm going to need and some screws to hold it in, so I'll just find them. That has got to be the crappiest wound coil I have ever seen. It's pretty bad. Okay, I found 2 clamps. I'm going to use these 2 self-tapping screws because they're only 5mm long. Like that. Okay, and they don't have to be overly tight, just enough to hold it in there. You could glue it if you want, but I'm not going to. Now I'm going to move on to these battery terminals. Now, as the access hole is there, I'm going to put my positive terminal on this side. So I'm going to put the negative one, this spring one, on the right hand side. Now I'm going to have to take them out to solder them, but for now I'm just going to put them in their home so I don't lose them. And I can always pull them out. Now I'm going to test fit the batteries. Alright, yep, that's not too bad. Now, moving on to the antenna, go through a little slot here. So I'm going to put that through the slot. And there's this little machine screw to go with it. It's the longest one out of the kit. I've got the feeling that I'm missing a terminal. Before I get too excited, I better put my solder tab in between the two, the plastic and the antenna, otherwise I'm not going to be able to attach a wire. Just so you know, there's actually a little nut that's supposed to go on the end of the screw. So just make sure to install that, otherwise it may work loose. There we have it there, one antenna. Okay, so now I can turn my attention to assembling the board, and I'm going to start with the resistors first. Got a bit of progress here. I've got all the capacitors on the board, resistors, and I even got the little on-off switch, aka volume control, mounted. Haven't mounted the capacitor yet, or the cans, or the 2 little inductors for the FM side yet. But what I'm going to move on to now is the ceramic filters. Now you're going to need to take note of that. Now on diagram it's marked CF1 and CF2. If you look down here, that's CF1, 1, 2, 3. That's CF2, 1, 2, 3. When you look at where they go, it doesn't denote which way it goes around. They were nice enough to provide a little diagram here of the schematic symbol with 1, 3 and 2, which means that side's pin 1, that side's pin 3, and the one that goes to the ground is pin 2. And we can see with CF1 it goes up to pin 16 of the IC at the pin 3 of the filter. So all you need to do is locate CF1, which is over here, turn the board over, and then just follow the traces up to pin 16 on the IC. So I'm going to mount those 2 ceramic filters. Okay, so when they're mounted on the board, both pin 3s face each other of each ceramic filter. Pin 3 over here on this one, pin 3 on this side on the other one. And that is the correct orientation. Now I'm going to move on to these 2 inductor coils. One's a 5.5 turn and one's a 4.5 turn. And if we look up here, L2 is the smaller one with 5.5 turns, and L3 is the 4.5 turn one, which is the larger one. L2 goes there, L3 goes there. And they be in. Now I can move on to the transformers. I apologise for the light on that last shot. I don't know what happened to the camera. Anyway, they got T2 marked on here twice. That T2 is actually the loop stick antenna. That should be marked as L1, really, because there's the description down there. The actual adjustable transformer T2 is over there, which goes between pins 1 and 2 of the IC. and I believe that's the AM oscillator coil, which is the red one. So I'm just going to look up the data sheet of that particular IC just now, just to make sure that that's the AM oscillator and it's not the FMIF. Okay, according to this, pin 5 of the IC is the AM oscillator, so pin 5 is here, that becomes T1. So T1 is the red one, which is the AM oscillator coil. T2, which comes off of pin 2. Pin 2 is part of the FM discriminator circuit. So I would assume that's the blue coil. There's a blue one here. See, that one's blue, so that would be the FM1, the FMIF. So this black one here would be T3. So I know which way around they all go, and if I verify that, it comes through the filter first. So it comes off pin 16, and pin 16 is the AM intermediate frequency in, so that would be the black coil. Okay, and that's all the transformers mounted. The red one, blue one, and the black one. Just the thing about this board diagram here, this is actually viewed from the copper side, not the component side. You're actually viewing the solder side. See? That's just a little bit of information there for you. It's utterly confusing, but I'm going on by the part markings on the board here. Okay, there's only two more components to mount. One's an LED and the other one is the tuning capacitor, but the thing about the condenser is, here's the ferrite rod with a bracket to mount it to. You'll notice it's got an elongated round hole cut into it, and you'll notice that it matches the top of the circuit board here. So that would get put on with the capacitor going down through it. Now with the capacitor, how do you know which one's C1, C2 and C3 and C4, etc.? You won't be able to see it on camera, but if you turn it over and you look under a magnifying glass, at the edge around here you'll see it's marked C1, C2, C3, C4 all the way around. So just look for that, and then you match that up with where it's marked CA and CB as C1 and C2 respectively. Then it's marked CC, CD. So that'll be 3 and 4 respectively. Okay, I've got the bracket for the coil and the capacitor screwed in, but not soldered yet because I was getting its placement correct and making sure all the leads came through the hole. So now I can go ahead and solder them, and then I'll move on to mounting the LED. Now with the LED, all I've done is I've placed it in the hole on the underside, placed the board in and lined up the LED underneath with the hole in the front, and now I know where it goes. I can just bend these leads over, and now I can solder it. And now with it soldered, and I'm just holding it there, it sits in the hole just perfectly. There's actually a hole there marked C. There's a hole between those two coils marked A. B is just on the other side of that electrolytic capacitor there. So B is the center tap, A is one end, the long end of the coil. So the ground, if you like. So this is pin, this one is A, which is on this side, B is the center tap, and C is the one coming off that end. Okay, now it comes time to mount the IC. All I did was just tap one pin into position, and now I can just go do the other side and just solder all the pins around like a normal IC. Don't worry too much if you bridge pins together. You can always heat it and use a solder sucker and suck it off, or some solder wick to make it nice and clean. Now when you're soldering this IC, you've got to be extremely careful. I would strongly advise you using solder wick to get the bridges out and not trying to use a solder sucker, because the amount of heat that I was putting through the circuit board managed to actually damage one of the traces going to a particular pin on the IC, so therefore I had no output. And I spent 2 hours trying to fix the problem and eventually ended up putting a piece of wire between the pin and the broken track. So yeah, be very careful when soldering to the board, because you can actually damage traces pretty easily and then wonder at the end why it's not working. Plus I was also getting very frustrated to the point after 2 hours I was going to throw it. So okay, as much of a pain in the butt that was, the IC is now soldered in. So now I can hook up the wiring that goes to the board, like the battery and the antenna, and then we can see if it makes some noise.
Going up into long lights. You can love. Crunched in that, but somehow was able to make sure.
It's alive! It's alive! Holy f***, it's alive! Do I win a cookie?
Someone just glided the bat at a full ball.
Okay, it works.
Keeps it out. The end of the over. India 1 for 11.
It's not aligned yet. First part of the alignment, I'm going to put all these trim capacitors at about half mesh. Also, the negative has to be on this side, mainly because that's how it's been embossed in the casing here, plus the negative wire isn't long enough. So yeah, it has to be that way around. And also I'm going to start with all these coils wound all the way out until they stop. Like that. Next you'll need another AM radio, and this one is tuned roughly to 985 kilohertz. Then I'm going to have the variable capacitor tuned all the way counterclockwise, in this case clockwise. Turn the oscillator screw. Until you hear the other radio do that. Now you know that it's oscillating.
Who I think fits this bill. I have great belief and faith in this man, but he needs to find it himself, I think. And he's becoming, since just in there last year, so he's still relatively quiet, still building his confidence, but yes, I want to keep encouraging him. And
Now I'm going to adjust the IF.
With self-doubt is none other than Richard, the bloke you met at the front of the story, who had been...
You want to find the peak. It's probably about as good as it's going to get.
As the sun slips behind just a wisp of cloud, it's a lovely day. Just the odd speck of cloud in the air. Looking both wider of the trees and round comes forward. A bit of bat and pad bounce.
Do you have an idea?
Will save from the closing fielder.
Alright, now I'm going to check where the pointer is on the scale. So now if you can see that it's around 900 and something, so this is 936, so that's about as accurate as it can get. So that's the AM side, it's not that hard to align. FM side needs an antenna. Okay, I've got the FM antenna connected now. Sounds a bit better. I'm just going to separate these coils a little bit. See, like goggles. Now the alignment of the AM side is pretty easy, but the FM side leaves a little bit to be desired because you've only really got the two trim caps on the back of the tuning condenser. C4, I believe it is the one that controls the oscillator, and C3 is the one that trims the antenna. So you've really got not much control over the alignment there, and it's very fiddly and very time consuming. And all the alignment is for basically bringing the scale into accuracy, so that when you put your tuning indicator in a particular position, that's the frequency it's receiving. As I say, it can be a bit tricky and time consuming, but patience is a virtue and it'll pay off eventually. Okay, this is about as good as I can get it. I fiddled with the oscillator adjuster, and this just adjusts the antenna, I think. Alright, that's about as good as I'm going to get it. There's this little plastic standoff that screws down into the front of the case, which allows the screw to go into the back, or from the back of the case. But that's about as good as I can get the FM side aligned. What I'm going to do is I'm going to put a drop of super glue on this AM coil to stop it from moving. And there we have it, the Superheterodyne pool radio. It's actually probably the crappiest bit of plastic work I've ever seen, but it works for the most part. So in review, it's not the hardest kit to build, but the instructions could have been a little bit more intuitive and would have helped if they were in English. And the alignment procedure, well, for the FM side can be a little bit tricky, and the FM receiver side doesn't work as well as the AM side. I've noticed the FM's a lot quieter in volume than the AM side, so that's to do with the design of the IC. That's beyond my control. Also, the final IF transformers on both the AM and the FM side don't really seem to have much effect on the overall peak of the output. So if you build this kit, good luck. But they say in the eBay article that it's a learning kit. Well, okay, learning where you've got to sort of like make your own instructions up. Okay. So I'm the Astro 13, and if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description. Anyway, I'll see you later. Have a great day.